One of the most famous regions in the Appalachian Mountains is found in Pennsylvania. Here we see an interesting pattern of long valleys followed by thin, long ridges. And right through the middle of it, the Susquehanna River is cutting through these ridges. Now, in a previous video, I already explained how the Susquehanna River cuts through the mountains like it does. So if you want an explanation of that, check it out. But I still haven't explained what formed these interesting long, thin ridges that we can see today. So in today's video, let's explain how this region of long, thin ridges formed going all along the Appalachian Mountains. So this entire region, stretching from New York down to Alabama, is known as the Valley and Ridge Physiographic Province. And a physiographic province is essentially one unified region that has similar physical features. Of course, in this case, this province is identified with having valleys and ridges that I've shown before. So the first step in forming these long ridges and valleys is the stratifying or layering of different rocks. And as this map shows, the Valley and Ridge province falls into the sedimentary Appalachians, which means almost all of the rocks in this area are comprised of sedimentary rocks. However, not all of these sedimentary rocks are the same. Some of these rocks are more resilient to weathering, while others are less resilient to weathering. The first of these rock layers formed around 550 million years ago when this region was actually underwater in a shallow ocean. Since this was a shallow ocean, it received a lot of sediment that eroded from the continental crust. And this formed a rock layer which is mostly composed of dolomites and limestones, which are rocks that are usually considered to be moderately durable. But they are weaker than the stronger sedimentary rock we will discuss later. This rock layer specifically is known as the Cambrian Ordovician carbonates, which are the blue on this map. The next layering process that is important to our story here took place around 450 million years ago. At this time, the Appalachian region has dramatically changed due to the uplift of new mountains during the Tectonic orogeny. This orogeny created a very long mountain range, spanning parts of our Appalachian Mountains today all the way up to Scotland. However, today has been mostly eroded and can only be observed in a few areas. But this new mountain range is important because our Valley and Ridge province falls right on the edge of this new mountain range. And this means that it fell in the foreland basin of the mountain range. A foreland basin forms as a result of the subduction that occurs in the area. Basically, as the land is subducting, it creates immense pressure on the mountains, and the crust actually bends downwards behind where the mountains are uplifting, creating an area of lower land that collects a lot of sediment. And this is exactly what happened with the Tectonic orogeny in our Valley and Ridge province here. So here is a diagram of what happened. Basically, we had the Tectonic orogeny and the foreland basin, which had the dip here. And as the mountains were rising, sediment got eroded off the mountain and got transported to the foreland basin, forming what is known as a clastic wedge. In our case, this clastic wedge is primarily sandstones and shales, which are also fairly weak sedimentary rock. So essentially, around 450 million years ago, our Valley and Ridge province would have looked like this, where you have the underlying metamorphic bedrock, the limestone and dolomite layer, and then the new clastic wedge. However, the tectonic mountains would continue to erode and form our next layer of rocks. And this is the final layer that is important to our story here. So this clastic wedge formed as the tectonic mountains were still rising and also being eroded at the same time. However, after they stopped rising, a lot of quartz from this volcanic arc was also eroded off the mountain, and this got mixed with the sand and sediment going down the mountain as well. So this formed a layer of sandstone that was also rich in quartz. This is known as orthoquartzite or quartz auronite. This quartz auronite layer is much more resistant to weathering than the other two layers because it has quartz embedded in it. So now we have this area around 350 million years ago with these three different rock layers. Here's a diagram which shows these different layers on top of each other. Here we got the third layer from the bottom, the limestone layer. Then on top of that, we would have this sandstone layer here, but it has been heavily eroded. And then on top of that, we have the orthoquartzite layer here. However, obviously, just the stratification does not explain the formation of these ridges and valleys. This is because after the quartz-rich layer was formed, these layers would have been in mostly uniform flat lines. So the next step in the creation of these ridges is folding and thrusting. This folding and thrusting occurred in another Appalachian mountain building event. The Appalachians have actually been built in 4 different orogenies, and this is why they are so fascinating geologically. But the event that folded and thrusted our layers of rock here was the Alleghanian orogeny. And during this mountain building event, the continent of Gondwana, which is a combination of Africa, South America, Australia, and even Antarctica, collided with the continent of Laurentia, which is modern-day North America, Europe, and Asia. These maps show the timeline of the formation of the Alleghanian orogeny. The most significant period for our Valley and Ridge province here was the early Permian, which formed the very long Alleghanian fold and thrust belt. This fold and thrust belt shaped the rock layers into features which are known as anticlines and synclines. So let's go over these 2 different types of folds and how they formed the ridges in our Valley and Ridge province. An example of a syncline are the Massanutten Mountains in the Shenandoah Valley in Virginia. Let's look at a diagram to see what's happening under the surface here. So here's what happened. Essentially, the land folded with also pressure from the other side, which created a dip down in this valley here and made it so that the younger rocks are here in the center and the older rocks are expanding up to the sides here. Specifically, this yellow that you see here would be our quartz-rich layer. And this blue, green, and pink layer I did not discuss, but these would just be newer layers formed from erosion. In contrast to the Massanutten Mountains, we have the Tuscarora Mountains, which are formed from an anticline. So here is a cross-section of the Tuscarora Mountains. And as you can see, it goes upwards and then bends down, leaving the newer rocks to be at the top here instead of in the valley that I mentioned for the syncline. So now we have this area after it had folded, so around 230 million years ago. But there is one more step in our process, and that, of course, is erosion. Before this erosion took place, these mountains would have resembled the lines and dotted lines that you can see here. They would have looked much different than what we can see today. However, after 230 million years of erosion through ice, water, wind, and even the sun, it has eroded away the weaker layers a lot easier than the quartz-rich layer. So this has left the anticlines and synclines to just be these long ridges of quartz-rich sediment, next to the valleys of the weaker sedimentary rock. So that is how this interesting pattern of long, continuous, wide valleys followed by very thin, long ridges has formed. If you enjoyed this video, consider subscribing, and if you have video suggestions, leave them in the comments below. But I will see you guys in the next video.